and we're gonna start the real-time scheduling. Okay. And SMP, systematic processing scheduling. Again, next Wednesday we don't have class, but you have quiz. Okay. So next Wednesday, make sure you study chapter 7, 8, 9. Okay. Because we don't have lecture, so I give you 3 quizzes. Quiz from chapter 7, chapter 8, chapter 9. Okay. So chapter 9, I give you something like this problem. I give you something like this. Okay. And you try to show me the scheduling like this one. Okay. And for next Wednesday. Okay. So make sure you study. your midterm. Oh, P.N. didn't order it. Okay, it's not in the order. Okay. Pichayut 40. Tempalit 40. 14, 214. Kasidan 2. Okay. Tasfik Ramen. Muk Suda. Muk Suda had no score. I don't have your score. Solasak 30. Pilot 21. Bapon 38. Bapon 38. Puttipong นวพล Okay, wait.
ผมมารับ
Bà Bốn. Okay, Chi Phan Dung. Thonapat 13. Thonapat Thanalat 18. Vaksin 27. Jilapat 06. Thanakan 12. Salawut 29. Okay. Puri 25. Thitapan 05. Thitapan 05. Pilapat 41. Pilapat 41. Nalonglit 09. Krishna 01. Tindanai 10. Tindanai 10. Pongsathon Tindanai 10. Pongsathon 18.
ไม่ได้น้อย
Bulihon 33. Sima 35. Are you 35? Name your number. Sima. Pechalat 92. 42. Pechalat 42. Thayakon 11. Thitawadi 08. Patra 22. Chayanon 36. ดัญลักษณ์15 I cannot read your name พัมพอง23 พัมพงอยู่พานุพงศ์ 45 สมเกียรติลักษิต26 ลักษิต26 แอสแลนด์สลัน28 จตุพัฒน์04 วะลันยู44 พานศิลป์พานุศิลป์39 อ้าว how come I don't have you วันปูนัม33 okay anybody else need haven't have ID ธนพัฒน์ Listen to the answer. Okay. I will give you the answer briefly. Okay. If you think that your score should be better than the way you see, if you think I mark it wrong, okay, talk to me after the class. Okay. Question 1. Okay. Question 1 asks you to write the class, okay, for those book in the library. Okay, so 1.1 is you have to write all the scope variables of this class, which has ISBN, title, authors, author site, price, major. Okay, like for example, ISBN 13 digit, integer cannot store 13 digit. Okay, you must use long or you can use string, okay, to be able to accept 13 digit. Okay, title could be string 5. Authors, it say that it has to be vector. If you don't use vector, you don't get credit for that. Okay, authors, the question asks you to use the vector class. Author size, the number, supposed to be int. The price, you must accept decimal point. You can use float or double. Int cannot store decimal point. Okay, major, we have 4 valid values, supposed to be like string. Okay. So then you can build a class variable, okay, with the type I mentioned. Constructor, you must pass these 3 arguments, ISBN, title, and price, and store in those 3 variables. Okay. For the vector, you should create a new object vector of the authors in the constructor. Okay, some of you didn't create here. Okay, you have an issue. Okay, you should create a new object type vector in here in the constructor, because after the first time they create a book. Okay, then they should have the object of the authors ready to add the authors in. Okay, even though no authors when you construct at the first time. Okay, 1.3 is to set major. This one mainly to dealing with those 4 valid values. Okay, you have to check whether the value that passed from the new major variable, okay, the parameter new major, you have to check whether it's comp sci, engineer, science, or liberal art. You have to use the if, okay, to check these strings. Okay, if you don't check them, you don't get full credit. Okay, and then after you check them, it is one of these 4 valid value. Okay, then you can put in the major variable of the class. Okay, the add author, since it is a vector, you can call add method of the vector, okay, to add the new author in. Okay, and every time that you add the author, you should increase the author size by 1. Okay, because author size to determine how many authors. Okay, so you can call add method, okay, to increase the author size. Okay. Okay, 1.5 is to dealing with the random access file. Okay, you must question after the class, not now. Okay, when you have a question, okay, we talk after the class. Anyone you are not agree with the way I grade, okay, that's why I ask you to listen from what I said first. Okay, if you think that you did what I said already, you should tell me after the class. Okay, and then we look at your paper individually. Okay, after the class. Okay, so 1.5 random access file. Okay, you need to use the random access file class. Okay, so you create a new object of random access file with the file name that given by user. You're supposed to get a file name from the user. The question said that. Okay, a file name as input from user. So you may use the scanner to get the name of the file. Okay, put in the object in the string and then use that file name as a part of parameter of constructor of new random access file. And you must have the mode of the opening this random access file. In read write. For this case, it has to be write because you're supposed to check the info, okay, of the file. Okay, and then this one to add a new book. Okay, into a file. Okay, so you're supposed to seek to the end of the file. After the end of the file, you're supposed to write. It's just like in the lab. Okay, so if the data type is string, you may need to use like write byte. Okay, if data type is int, you use write int. Okay, so it depends on the type of each of those class variable. Okay, write byte, write double. Okay. And since it's a random access file, you should choose a specific size. Okay, otherwise random access file won't work if you don't know exactly the size of each of those value, especially when they're dealing with a string. The size of the string could be any byte. Unlike int double, the size is fixed. Okay, you don't have to extend the value to have a bigger size. Okay, and using random access file, you have to cache. Use try and catch. Okay, or throw. Okay, for the error. Okay, you don't do try and catch or throw, then you don't get full credit. Okay. Question 2. Okay, question 2 is just like in the quiz. Okay, that you have to do. Number 1, you have to show me the fn, the complexity function. Okay, by look at all these statements. Okay, like for example, the first one. Okay, sum equals 0, I equal 1, that execute only one time. I less than n, less than or equal n, I plus. This one gonna go n loop, 1 to n. So I plus we execute n time. I less than or equal n, we execute n plus 1 time. So you have to do like the way we did, okay, many times during the lecture and the quiz. Okay, so you have to show me fn. After you show me fn, then you have to show me big O. Okay, to show me big O, you have to state that your function fn must be less than or equal, okay, the constant multiplied with the complexity class, like n square, n log n, but you must have a constant and capital N to determine whether this less than or equal, fn less than or equal this class and from which value of n. Okay, you have to show n greater than or equal 1. Okay, after you show me big O, you have to show me big omega first before you show me big theta. Okay, if you don't show me big omega, you should not be able to show me big theta. So big omega is the opposite. You show fn is bigger than or equal. Okay, the constant multiplied with the class of the one that you choose for big omega. Okay, and if big O and big omega are the same class, then you show me the big theta. And then you show me the sum. Okay. Okay, so the sum of the first one, I think is n times n plus 1 over 2, right? That is the amount of time of adding 1 at a time. Okay. Question 2.2. Question 1 is big theta of n square. Question 2, I think it also n square. Okay, but the summation is, I think it's 5n square. Okay, and question 3. Question 3 is been cutting down by half. J, okay, had been cut by half, divided by 2 all the time. So the J loop is go only log n. Because we cut half, log n base 2. Okay, but the I loop go to n. So it's overall is big theta of n log n. Okay, that's a 2.3. Question 3, you have to explain me what is the singly linked list and doubly linked list. And you have to tell me pros and cons. What the good thing about singly linked list, what the bad thing about singly linked list. Okay, so you compare between the two. Good point of singly linked list, okay, compare with the good point of doubly linked list. Likely to be like singly linked list, okay, is simple to implement. Okay, the time that you run for singly linked list, okay, is linear. Okay, and the con of singly linked list is that singly linked list it works only one way. Okay, compare with doubly linked list, you can work backward. So in some method, doubly linked list, you can start from the tail and move previous. Okay, so then the amount of time, the complexity, okay, that you spend on some method double linked list can perform faster than single linked list because it starts from the end, can start from the end. But single linked list cannot start from the end. Okay, but the cons of double linked list have more overhead of pointer because double linked list need to have previous pointer. So the memory that you need for double linked list is likely to be more than the single linked list. Okay, 3.2 you compare single linked list with skip list. Okay, so to compare with skip list, okay, single linked list is linear. The development is simple. Okay, the memory doesn't use much. Compared with skip list, you need to have more memory. Okay, to store the multiple link list. Okay, to point over. Okay, many nodes. Okay, so skip list we use a lot more memory. Okay, than the single linked list. But the pros of skip list is that skip list can search value in the list faster because you skip. Okay, and the data that you store in the skip list should be in the order. Okay, unlike the single linked list. Single linked list doesn't say it has to be in the order. But skip list, to be able to skip the data, if it's not in the order, you cannot really skip even though you have multiple lists. Okay, that's 3.2. 3.3, order from lowest efficiency to highest. Lowest efficiency is a good or bad thing? You want high or low? You want high efficiency, not low, okay? So lowest efficiency for this case is 2 power by n. Okay, so the highest efficiency is the best thing. The best thing is a constant. Okay, so the answer is 2 to the n square, n log n, and then log n, and then constant. Okay, constant is the best. You can run program in constant. Okay, it means that it doesn't matter how big or small of the input, the time of execution is the same. Okay, all right, question 4. Write a singly linked list. Okay, 4.1 you have to define what the node in singly linked list and what the class variable. Okay, so here you have head, tail. Okay, the node have info, have next. Okay, but head, tail does not belong to the node. When you write head and tail, you have to write in 4.2. 4.2 is the class for the linked list. 4.1 is for the node. But if 4.1 for the node doesn't have head, tail. The node have next. Okay, have the value that you want to store. Okay, and also the array that to store, that store the pointer that point every 10 value. That's a part of the list. That's not a node. Okay, so the array that you saw in the picture is a part of the list. So the list is supposed to have this array. So the constructor of the list, you should declare the new object of the array. Okay. Okay, so most of you get point off due to the array. Okay, because the question states that you must dealing with this array. This array will help in question that you want to search for question. The last question of 4.2, the last method. Okay, if you don't have that array, you get point off. Okay, so question 5, add to tail. Okay, it's similar to the one that we have learned, but one more thing that you have to do is that after you add, you have to check whether the member that you add is a member of tens. For example, the member 0, member you could say 0, 10, 20, 30. You have to check the amount. Okay, if you have every 10, you're gonna dealing with this array. Okay, if you don't deal with array, you get point off. Okay, because the question said that you have to maintain this array of every 10 member. Okay, search element, just use a simple search. Go next. Okay, temp equal start from head. Okay, while temp less than, not less than, sorry, while temp is not equal to now, so you go temp equal temp dot next. Okay, and keep searching for the EL. If you found it, you return the value in it. But question last one, search by position. This one you must use those array because the array tell you the position number for every 10 member. Okay, if you don't use the array to maintain every 10 member, you get point off for sure, a big point. Okay, because this one mentioned that. Okay, you must use that array. If you use just simple search, then you won't get high score for sure. Okay. 5.1 spare table. This is just like what we learned. Okay. Spare table is a two-dimensional data structure that you store value just like in the table. But the table is have lot of empty space, empty cell that we have no value to store. Okay, so the disadvantage is that we reserve a big chunk of memory for two-dimensional array, but we not really use all of them. We have a lot of space left unused. Okay, so that is the first major disadvantage. You store a lot of empty cell. And number two, if you store something like this, it's going to take a lot of time to search because you're going to search for the empty thing all the time. I mean, you're going to keep checking empty cell. That's not necessary to check. Okay, so the second disadvantage is likely that the spare table, okay, you may have a chance that you're going to search for them longer. It takes time. Okay, so 5.2, you use data structure that we learned in the class, use the pointers, okay, like linked list in 2 dimensions, one node, okay, point among nodes under the same column, and another list is point among nodes under the same row. Okay, so if you use the same example as the one we learned, the class and the ID of student, okay, you have one pointer, point among object under the same student, and another dimension, a point among object under the same course. Okay, so the advantage is that we don't have to store all those, okay, no data like the student who haven't learned that course. Okay, so when you search, you can skip to only the data that valid in this system. Okay, that's the spare table. Question 6, to add two numbers using stack. Okay, this one you must use 3 stacks, 2 stacks for the operands, 2 number. You must push the number. Okay, and you read number from left to right, and the way computer read from left to right, 1 digit at a time, and push in the stack. And then after that you add just like the way we look in the class. Pop the top number out for each stack, and then add them up and put the result in another stack. Why sometimes you may have carry that you have to, okay, take the carry to the next addition, then add them up. Okay, many of you didn't get the result at the end. You put the data in your stack, and at the end you don't pop them out. You don't pop them out, the data remain in the stack, and we don't know the answer. You must pop out the data from the result stack. You don't pop out, you cannot show the answer to user. It remains in the stack. Okay, so 6.2, the reason we use the stack because, okay, the way we read data from the series of digits, we read from left to right, but the way we add from right to left of the number. So look like we read and push it down at the bottom, and the way we add from the last one that we push in. Okay, we add from the back. So that's why we use the stack. Last in, first out. Okay, the last digit that come in will be the first one that it come out to add. Okay. Last one, the Q. Question 7, this one just like the one that we did in class. Okay, the Q class. Okay, you need to have 2 pointer in the queue because the queue have first and last. Okay, the DQ need to DQ from first, NQ and Q to the last. Okay, you must have an array to store this value. Okay, just like the one that we show in the lecture. Okay, so you need to do like is empty, is full to test whether it's empty or full. Empty is when the first last pointer is below 0 because we make it minus 1. You can make it something else. Many of you may use a little bit different, okay, Q that you implement. It's okay. Okay, doesn't have to be exactly. Somebody use first last and start with 0. It's up to you, but you cannot show me the method that work with your the way you define. Okay, so the full. Okay, if first is at 0, last at the end, that's a full. Or the first and the last come back behind the first, that's the full. Okay, then you have NQ, DQ. Okay, you have to make sure that you use DQ, you DQ from first, and NQ at the last. Okay, DQ, you have to check whether the Q is empty or not. If Q empty, you cannot DQ. But by NQ, you have to check whether it's full. If it's full, you cannot NQ. Okay, and you have to check dealing with when we have empty Q. Okay, the first last is minus 0 or minus 1. What we do with it? Okay, and you have to keep changing the value of first and last. Keep increasing. If you reach the end of the array, you have to go back first and last to restart at 0. Okay, so just like the lecture. Okay, okay. That the midterm. Okay, okay. I have to collect your paper back. Okay, you want to take a look, you take a look now, and then you have to return the paper. Okay, because it's a rule of the university that the school have to collect your paper for 1 year. Okay, the SIT will keep this paper in SIT for 1 year. Okay, okay, so you want to look at your paper, you look at it now. Okay, if you have question about the way I grade your work, okay, talk to me after the class. Okay, we discuss. If I mark it wrong, I can keep your point back. Okay, but likely not. Okay, depend. Okay, we talk. Okay. Number 2, what you should do is to add up all your score together and find out whether the total score is the same one with the number that circle on the second page or not. If it's not the same, let me know. Okay, because it could be possible that we have error when we typing your score in the Excel file. Okay. All right. Look at your paper. If you think that you have question about your exam, okay, or I put the score wrong, let me know. Okay. If not, return me the paper. Okay. It doesn't matter you have comment or no comment, return me paper. Okay, but we will talk for the one that have error or the one that you will not agree with the way I grade. Okay, when you finish, return me the paper. For the one who fail, okay, what did fail mean? Wait. Okay, to pass this class, okay, you need 60% to pass a C. If your score below 60%, you are not in good condition. Passing for me is passing C, not passing F. Okay? You are the freshman. You should not maintain your grade below 2.0. Okay? There is a rule that on the first year, if you cannot get out of, I think it's 1.75. On the second semester, you will be kicked out. Okay? The first semester is 1.5. Second semester, you have to maintain at least 1.75. But you should do at least 2.0 for your GPA. Because if you keep below 2.0 for, I think, 4 consecutive semesters, you'll be kicked out also. Okay? You must not maintain your probation for more than 4 semesters. If you are on probation for more than the 4th semester, after that, you will be, okay, get out from this school. Okay? Okay, 60% of 90. Okay, the total score is 90. Okay, so 60% of 90 is about what? about almost 60, maybe 55. Okay. If your score is below 55, you are not in good condition. Okay. Below 45 is only 50%. Okay. If your score is lower than 55, talk to me after the class. Okay. You gotta do something to make yourself understand. Okay. And be able to show me that you understand better than what you have now. Okay? So we're going to do something about your score. Okay? For the one who below 55, okay, so stay with me after the class and we talk. What should we do? Okay? For the one above 55, you are okay. You are not in the urgent situation. Then you are okay. Okay? For the one below 55, you may have something to do. Whatever you do, you will not go higher than 55. Okay? Otherwise, it's unfair for the person who are above 55. They cannot do anything about their score. Okay? My grade, I use the scale, not curve. What does it mean? It means that, okay, my scale is 60%. If all of you above 60%, then no one get below C. Okay? If all of you get below 60%, then all of you get below C. It's not a curve. Okay? It's a scale. Okay? At this point, if you pass, you pass. It doesn't matter what your friend have. Okay? I don't use the scale. I don't use the curve. Sorry. I use the scale. Okay? C is about 60%. If you cannot maintain 60%, you are not in good shape for the C. Understand? Okay. A is about 85%. So far, I don't think anyone get an A. Okay. The highest score is 78. Still not enough for the A. But still, you have homework, you have lab. Okay. And you have final for 40%. Okay, so if your score not getting A now, it doesn't mean you don't get the A. You still have a good chance to get the A. If you do all the homework, okay, finish all the lab, okay, and try to do midterm, okay, in the good score, then you may have to get an A. Okay? And the same thing with the person who get low score, below 55, which is from here all the way down. Okay, I don't know these two persons, probably not in here anymore. 29 students below 55. 11 students maintaining the C, good. Okay, so these 29 students supposed to see me after the class. Okay, and then if you do the one that I asked you, okay, to do and you do them well, then you're gonna get the score, okay, to the C level, which is 55, but not higher than 55. Okay, otherwise unfair to the person who get above 55. Okay, F is about 40%. If you are maintaining below 40%, you probably get F for sure. A about 85%, C is about 60%. Don't get below 40%, you are not in good condition, you get F. Even though D is not good. If you think that you are really, really low and you cannot improve your score for sure, I recommend you to withdraw. Okay? Withdraw is better than getting F because you don't get a grade. You don't get a grade, your GPA will not hurt. Okay? But the problem of withdraw is that if you withdraw from the class, you cannot continue the next class for sure. The next class after this class is algorithm. If you withdraw, you cannot register algorithm. But if you get F, you can register the next class. The university policy said that when students complete the course, it doesn't matter what grade you get, you can continue the next course as long as you complete, even though you get F. But if you withdraw, you are not complete the course because you withdraw in the middle. Okay, then you cannot continue for the next course if that course have this class as a prerequisite. Okay, so that's the rule of the university. Any question? Okay, give me back the paper. Okay, we have to collect them. Okay, if you have issue with your paper, let me know. I put your paper in a separate pile. Or the one get below 55, we talk after this. Okay, this is not the end of the world. Okay.
The others don't even want to return the paper themselves.
Okay. Okay, even though you get low score, okay, don't kill yourself tonight. Okay, it is not the end. We still have something else to make yourself a better person, better knowledgeable. Anyone have problem with your paper? You gotta tell me first, okay, before I put them in a pile. Any question? No? Okay, Mr. 11, return me paper first, and then we talk after the class. Any question? Any problem? No? ขนาดอะไรยังดิ out of 9 ดิฮะ Where's your paper? I have your paper back. Anyone who doesn't give me paper, you get F, okay? Mr. 11, you already returned me paper? You have no question now? Okay. Let's study, and then after that we talk about your paper later. What did we up to? Did we do this? Search? A node composed of 3 things, a value that we want to store, and 2 pointers, left and right? Binary search tree. Yes or no? Okay. You didn't understand? Okay. Again, for binary search tree, okay, a node class, okay, you will have the value that you want to store. If the value is in, okay, you say in info. If for the second binary search tree, if the value that you want to store is word, then you use the string. Okay, it depends, whatever info you want to store. Okay, and then you must have two pointer, okay, that point to node. One is the left pointer, point to the left child, and another one is a pointer that point to the right child. Okay, so a node composed of these three values for sure in the binary search tree. Okay, so when you construct a new node, okay, you may not have left child, right child. Okay, you may set left child, right child to be null. Okay, if you know the value, you set info to that value. Okay, but in terms of the tree, binary search tree, okay, for the tree, okay, you maintain one pointer, we call is the root. Okay, root will point to the top node. Okay, and then the root after that is relationship among nodes. Okay, so the root point to one, okay, point to one node. Okay, and then that node will point to other node, and other node will point to any other node. Okay, so the tree maintain only one thing, the root. After that, the node, they will maintain the tree by themselves. Okay, but the method in the root, okay, you should have the method that to be able to add a new node. Okay, you should have the method to be able to delete a node from the tree. Okay, or you could have a method to change value of the node in the tree. Let's say I call update node, which is the value on the tree. Okay, last time we look at the new node. Okay, to add a node into the tree. Okay, there is one method that most of the data structure must have, is to let people to access the data in the data structure, which is to be able to see, to be able to search, okay, that value, that member. Okay, so for this example, you may have a search method to search for the element in this tree. If the element, let's say this one, okay, the info will be int. Okay, then for that case, you should be able to search for that info. Let's say EL, element that you want to search. Okay. Okay, since it is a binary search tree, one big property of binary search tree is what? What the property of binary search tree? The tree to help searching. What the major property? Divide? No. What the major property of binary search tree? Major character of this tree? One node, okay, have two children at most, that's the binary. Make it binary for search. What the property? Not two children. At most two children is a binary tree. What the major property of all these nodes? You can see that. Huh? The left child has to have value less than parent. Not only the left child, the whole subtree of the left of this node, any node on the left of this node, they are smaller than that node. Okay? And on the other side, on the right of that node, all of these nodes must be bigger than that node. Okay? Including this one, the left of this one must be smaller than this. And the right of this one, all of this must be bigger than that. That's the major property of this tree. To make sure that the tree has a symmetric way to search the value. Because if you don't organize them in the order, you don't know left or right to go. Okay, but here you know left or right by look at the value itself, whether it's bigger or smaller compared with that node. Okay? Okay, so that if we want to search on that tree, okay, we're going to use this property. Whether go left or go right depend on its less or its more. Okay, smaller or bigger. So to search on the tree, you're gonna start, okay, one pointer that point to node temp. Your temp must start from root. That's the tree. You always start from root. And then after that, you're gonna keep going down to this branch, okay, to find this value. Okay, so we're gonna start doing this as long as the temp is what? Not equal to now. If it's not equal to now, we're gonna keep go down, okay, on this tree, go down along the tree. Okay. What we do in this loop, we check if the one that temp point to, okay, have the info, temp.info, what? We either go left or right. Okay, we know down here, okay, we're gonna say temp go down to the left will be temp equal to temp dot left when we go down to the left. We look at our value that we want to search and the value that temp point to. If the value that we want to search is smaller than temp.info. If it's smaller, value that we want to find smaller, we go to the left. For example, if we want to search for 12, we start from here. EL is 12. Right now, temp start from here. Is it EL smaller than temp.info or bigger? If my EL is 12. 12 is smaller than temp info. So if it's smaller, so then we're going to move temp equal temp dot left. Okay. If my EL, which is 12, is bigger than this temp.info, I'm going to move right. Okay. So two conditions. If the EL is smaller than temp.info, we move left. Okay. Else, okay, if my EL is bigger than my temp.info, we're gonna move right. Temp equal temp dot right. Okay, we keep do left, right, 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 left, right, right, left, right, 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 left. Depend on left or small. Until what? Until what? Until we found it. Okay, until we found it, we may return. Okay, so in other words, not less than, not bigger than, it means equal. Okay, not less, not more, it means equal. So L, if it's equal, it means we found it. So if we found it, we do whatever we want to do. Okay, we may return this node, we may return this temp. Okay, since temp is a node, so then we may return this node. Or maybe just print found it. Do whatever you want after you found it. Okay? But it can be returned and then the loop stops. Okay? But again, we may get out of this loop without finding this object. For example, if I search for number 5 in this tree, can I find number 5? Okay, 5 less than 13, temp equal temp dot left. 5 less than 10, temp equal temp dot left. 5 bigger than 2, temp equal temp dot right, because it's bigger. Now, when I get to here, my temp is now. When my temp is now, my loop will terminate. When my loop terminates, we get out under this. When I get out under this, it means I could not find it. Okay, so if I could not find it somewhere down here, I may say I return now. Or print something that I could not find it. Okay? Understand? Simple. Okay, so that's the to search. Okay, if it's the same, then you found it. If it's not the same, depend. If it's the one that you search is smaller than the one that the temp for this temp is a p, 0.2, we go left. We either go left when it's the one that we search smaller. When the one that we search is bigger, we go right. Okay, that's the search. Okay, now they have something else, not only search. They have add that I already showed you last time. Add is similar to search. Okay, you keep moving down until you found the leaf that proper place to add. Then we create a new node and make either left or right point to it. Okay, that's it. Add last time. Okay. Later on we may do delete and update, but not now. It's a little bit more complex. We do maybe a couple of weeks from now. Okay, huh? I did show the add last time. You want me to show again? Okay, maybe we do again in the lab, maybe. Okay, it's almost the same, except that we're gonna go until we get to the place which is already out. Okay, after that we create a new node and make it point to. But it's still the similar method. We're gonna either go left or right. Like for example, if you're going to add, let's say add number 5. Okay, you still need to go less than 5 less than 13, go left. Less than 10, go left. More than 2, go right. Until we found it now. Then we're gonna start create a new node and make this one dot right point to it. The question is dot right or dot left. From there it depends. If the value is bigger, it's dot right. If the value is smaller, it's going to be dot left to point to it. Okay, but the major part is to moving along the tree by checking the more or less. Smaller or bigger. Sorry. Okay. All right. We almost running out of time. Actually. Okay. Before we go home, you done? Actually, I should be done because you need a searching. You want to find 25. Why is the 25? We start from root, right? Why 25 bigger than 20? Okay, so go to the right. Less than 30, go to the left. We found it. Okay, but let's say we search 28. What we gonna do? 28. Right, and then left. Right, and then what? And then fail. Agree? Not success. Another word. Agree? So you go right, left, right, fail. Could not find it because 28 is not in there. Okay, that is now we search. Okay. All right, homework. Okay, do later, not now. Okay. Okay. Next time we look at the tree traversal. Okay, deletion coming up later. A little bit more complex to do delete. Okay. But we look at the tree traversal first next time. I see you tomorrow in the lab. The one who failed below 55 remain here. The one that above 55 you can go. Oh, we have to talk quickly. Jan Ponchai is coming. The one who get below 55, you have to talk to me. It's almost the whole class. who are really below Okay, practice this problem, okay, in Java, okay, and we're gonna set a date. From I suggest
ไม่ได้เลยเพราะว่าอาทิตย์เดียวอีกอาทิตย์เดียวเลย
what? We have 2 weeks.